Hello students, welcome back. This question is from GATE 2007 exam. It is for 2 marks. They have given you this circuit in the question. Also they have mentioned there is a small fault in this circuit. The fault is this point T, it is always connected to ground. So that means this one input of NOR gate will never be 1. Okay, it will always remain 0. And we are required to find which inputs. We are required to find out the values of these inputs x1, x2, x3, which when applied to this circuit will help us to detect the fault. Okay. Now in my theory lectures, I've already told you that such faults can be detected by changing the inputs. Let us see a small example here. In AND gate, if we apply inputs 1, 1, the expected output is also 1 because 1 and 1 will be 1. But if one of the inputs is grounded, one of the inputs is always connected to ground. That means for AND gate, that specific input can never be high. Even if I apply 1, 1 here, the input that this AND gate is getting will be 1, 0. Okay. And because of this 0, it will output a 0. Now what I'll see is, I applied 1, 1, I'm getting output 0. I'll just sense that there is some fault in this circuit. Okay. We are required to do the same thing here. We want to determine values of x1, x2, x3 such that this fault is detected. They've given you these 4 options. Okay. Now let us analyze this NOR gate. I've drawn the truth table for NOR. That means at these 2 inputs, we can have these 4 combinations and they are the expected outputs. Let us see. What if I try 1, 1? If I try to apply 1 and 1 here, if the final output is 0, I can be sure there is no fault. Okay. Let's analyze it further. You see, if I apply 1, 1, I somehow make this output 1 and I somehow make this output also 1. Now what will happen is, here you will get 1 because there is no fault in this wire. But this wire has a fault. It will change the output to 0. That means 1, 0. This is what this NOT gate is getting. On 1, 0, the output is 0. On 1, 1 also, the output is 1. We can't actually detect the fault because the expected output is similar as what we are getting, even though if this fault still exists. Okay. That means using 1, 1, we cannot detect this fault because in both of the cases, the output is same. Okay, so let's try this one. What if I try this input? What I'm saying is, say I somehow manage to make this output as 1 and this output as 0. Okay. Will I be able to detect the fault in this case? Let us see. See, this one will reach here as it is. This 0 will also reach here as it is because this one is connected to ground. Okay. I'm sorry, this is 0. This 0 is reaching here as it is. Okay. In this case, the fault was not able to alter the input at all. That means we still can't detect our fault. Okay. So this is of no use. Let's try applying this input. If I apply 0, 0, you can see I'm trying to bring 0 here as well as 0 here. So the input that I am applying 0, 0 is the input that this NOR gate is going to get. Okay. In this case also, this fault doesn't alter the input at all. So we can't detect the fault. Now you have seen this one is not of any use, this one and this one. All 3 are not of any use. Let's analyze this one. What I am trying to do is, I somehow want to make this gate's output 0 and this gate's output 1. Okay. Let us see, will we be able to detect this fault? This is 0, this is 1. 0 will reach here, but 1 will not reach here because this point is grounded. Okay. Sorry, this 1 will not reach here, we'll get a 0 at this place. Now you see, we applied this input to the final gate, which is a NOR in this case. But this NOR is actually getting 0, 0. Okay. The expected output is 0. But if there exists such a fault, we are going to get 1. Okay. Now, if even on applying 0, 1, I get 1 on output, I can be sure that there is some fault in this circuit. Okay. Now let's try to somehow make this gate's output 0 and this gate's output as 1. Okay, let's try it. This output is 0, means this one should be 0, this one should be 0. Both of them should be 0. Okay. This one should be 0, means x4 must be 0. So value of x4 is fixed. This is 0. Okay. If x4 is 0, one of the inputs of AND gate is 0. That means this AND gate will output as 0. Now you can see there is no possibility that I somehow get 0 here and a 1 here. Okay. Because x4, if it is 0, this one will certainly output 0. Okay. But we want a 1 here. So no such input values exist such that this fault can be tested. Okay. That means answer is none of these.